Can you break a ruler with just one sheet of paper? Have you ever thought that a single sheet of paper could stop you from breaking a wooden ruler with your own hands? Sounds unbelievable, right? I mean, it's paper. But in today's experiment, we're going to test this surprising idea and reveal the invisible force that makes it all happen. Hey, curious minds. Welcome back to the channel, where physics turns into real-world fun. Today's experiment is quick, easy, and honestly, kind of mind-blowing. You only need a few items. But what you'll learn is something that will make you think about the air around you in a whole new way. Let's dive into it. Here's what you'll need for this experiment. A standard wooden ruler, a table with a flat surface, one full-size sheet of regular paper. Your hand got those ready. Great. Now, here's what we're going to try. Step 1. Take your wooden ruler and slide about 1/3 of it off the edge of the table. Let the rest stay flat on the table. Now try this. Smack down quickly on the hanging end of the ruler with your hand. Be careful, but give it a good hit. What happens? The ruler flies off the table, right? That's expected. There's nothing really holding it down. Now let's try it again, but this time with a twist. Place the ruler on the table the same way, with 1/3 hanging off. But now, lay your piece of paper flat on top of the part of the ruler that's on the table. Ready? Now give the same kind of hit to the hanging end of the ruler. What just happened? The ruler doesn't fly off. In fact, it might even snap clean in too before it moves from under the paper. This isn't some magic trick, it's the power of air pressure in action. So let's break this down simply. Air might feel like nothing, but it actually weighs a lot. A single sheet of paper lying flat covers a large surface area. That means the air above the paper is applying force across every little bit of that surface. Even though we don't feel it, atmospheric pressure is constantly pushing down on everything around, accentuating that piece of paper. When you hit the end of the ruler, you're trying to lift the part that's under the paper. But now, you're working against the entire weight of the air, pressing down. And that's a lot more than you think. This experiment is a great example of air pressure at work, surface area and force, and Newton's laws in action. Let's look at some numbers, don't worry. No heavy math here. Atmospheric pressure at sea level is about 14.7 pounds per square inch. That means, if your paper is about 8 inches by 11 inches, it has over 1,000 pounds of air pressing down on it. Mind equals blown. The reason we don't notice this pressure in daily life is because it is evenly distributed. Here's something extra fun to try. What happens if you use a thicker or larger sheet of paper? What if you fold the paper or use 2 sheets? Experiment with different sizes and materials. You'll find that the larger the surface area and the flatter the contact with the table, the more dramatic the result. You could even use this experiment to explore topics like force and motion, gravity versus pressure, the relationship between mass and area. It's an amazing science learning moment using just things you already have around the house or classroom. And the best part? It's totally safe and takes less than a minute to set up. So, here's a challenge for you. Can you think of any other situations in daily life where air pressure holds something in place? Think about vacuum-sealed food, suction cups, or even airplane wings. Let me know your thoughts in the comments. I'd love to hear what invisible forces you notice around you. And hey, if this experiment surprised you, share it with a friend or a teacher. Trust me, they'll be impressed when you show them how one piece of paper can break a ruler. If you had fun and learned something new today, don't forget to give this video a thumbs up and subscribe for more awesome, simple experiments that reveal the hidden laws of physics in everyday life. Until next time, stay curious, stay clever, and keep exploring the invisible forces that shape our world. Because science isn't just in textbooks, it's right under your nose.